Alright, welcome back to another video, and this is the part 2 of the video. We will, we stopped in the first part. We learned how decision trees work, and specifically we learned about the CART algorithm and how that works, and all the mathematical background that we needed to gain before we could just move on to the implementation part, which is not that hard, because considering that we were using the Python library scikit-learn, it's not going to be that hard. It's just we just need to write a few lines of code for that to happen. So it was very important for us to learn what was the mathematical background behind the main model that we are going to be using, right? So as I promised earlier, that we will be implementing this using Python, so let's just get going with it. Alright, so the libraries we need to use in this for this particular implementation are going to be pandas. So I'm just going to go ahead and import pandas. Whoops. Alright, and then we also need to use the scikit-learn library. So from scikit-learn, I need to import decision tree, right? So first of all, I'm just going to go ahead and import decision tree. So the decision tree has the decision tree classifier, right? So we have a decision tree regressor and a classifier. I will be using decision tree classifier because obviously we need to perform classification and not regression, right? So the next thing we need to import is we need to import the pre-processing library, which is simply going to help us perform the encoding. And you will see why I'm actually importing all these libraries. So if you don't understand what's happening here and what these libraries are going to do, so you don't have to worry about that right now. All you need to do is you just need to focus and understand what I'm doing right now. Okay. So oops, I forgot to add the import keyword there. And so scikit-learn dot what else do we have? Yeah, so we also need to import the train test split function, which is going to be used for splitting our data into the training and testing. Why am I doing this? Is because well, there's a thing called a training data and a testing data. So data is divided into two things. So in the further videos, you will see that in every single model that we are going to be learning, we have to split our data into two sets. So the first one is going to be training data and the testing data. First is training data and testing data. And what are these two data? Well, I'm going to be explaining as I code. So first of all, I've just imported these libraries. As you can see right now, I have imported all of them. And now, as you can see, I have prepared my data here. You can see this is a simple data set that I have, and what I'm doing here is I've just written all of the columns that we learned. The only difference is that in the windy column that we learned about, so you can see the data set right here. Well, the windy had the weak and strong, but instead I have the false and true, and it doesn't matter because these are just normal attributes, or simply you can say they're just binary attributes. So all we need to do is we need to convert them into zeros and ones. And here you can see that the rainy, overcast, and sunny. Let me just go ahead and code them up so that we can see them clearly and how they look like, right? So dataset.pd is simply just the aliases for calling pandas. So I'm just reading the CSV file, and the name of the file was temp.csv. And right now I'm just gonna go ahead and print this data set just so that you can see. And you can see right now that we have imported the data set right away. And the outlook has had the nominal attributes rainy, overcast, sunny. So we need to encode them too. We need to so the encoded values for this is going to be, let's say overcast becomes 0, rainy becomes 1, and sunny becomes 2, right? And similarly we need to encode this, because why do we need to encode this is because our machine learning model in Python don't understand the string values. So obviously we need to feed in the numbers so that they get trained on those numbers, right? So we need to specify the numbers here. So we need to convert this whole data set into numbers, right? And it's going to be quite it's a very easy thing to do, in considering that we're using Python here. So we don't necessarily need to do a lot of things. I could definitely create a code from scratch using pandas to encode this, but I'm just going to use label encoder because we have one, right? So we don't have to use anything else, right? So let's just start. First of all, let's just remove this unnecessary column that we need. We don't need this column, right? So we don't need this ID column. We already have an ID right here. So for that, I'm just gonna go ahead and say dataset equals pd dot data frame. F is going to be capital, and now we need to say data. Data is a keyword argument that you need to send into the pd dot data frame, and then I need to just simply go ahead and say, well, all of the columns in the data set, you just need to include those columns, right? So I'm just going to say dataset dot ilog, and what do we need to say? Well, simple. So we need to include all the rows, and then from 1 to 5, so all the columns. So if I just say 6, it means that I'm saying 0, 1, 2, 3, 4, right? And if I just say like this, okay, I'm going to show you. So it's like 0, 1, 2, 3, 4. So I need to say 5 here, right? And then we also need to say dot values. So all the values in these columns should be fetched right away, right? And finally, I'm going to specify all the column names. So columns equals, and then we can just simply specify those names. The names are Outlook, and we have temperature. I could just simply use the names from beneath, but I'm just going to go ahead and set the names myself, so I don't have anything case sensitive. I don't want this caps. I don't want these capital letters in the beginning of the name, so I'm just naming them myself. I could use the same names that I have in the dataset, but just for the sake of showing you guys, I'm doing this from scratch. Actually, not from scratch. I'm using pandas, obviously. So we have an error. Awesome. So we have an error, right? And the error is, well, we're using 5 columns, so why are we even using 5 columns? So why are we even using 6? So we need to use 6 here, right? Or simply we can say C0 from 5. Okay, so we need to include, we wanted to exclude that column, right? So this is exactly why I had to use 6. And as you can see now, we have formed the dataset, and it looks like it looks proper, right? So it has all the columns we needed, and now we can just go ahead and start encoding all of these columns so that it looks something that our machine learning model can understand, right? So we're gonna do that now. First of all, for this to work, I'm just gonna go ahead and create a label encoder. So how do we create a label encoder? Well, you can just simply say LE, which is simply a variable name, and I'm just gonna say label encoder. So this is exactly how you create the label encoder in Python using the scikit-learn library. As you can see that I have imported label encoder here, and then we want to say, well, first of all, I'm just going to go ahead and say dataset underscore encoded. So we need to actually create another dataset which is encoded, right? So we can just simply keep track of what it encoded for us, right? So this is exactly why I'm creating a new variable, so that we can keep track of what our previous dataset looks like and what this encoded dataset looks like, right? So now I'm just gonna go ahead and say dataset dot ilog, and I'm just gonna say all the rows, just take all the rows, and from 0 to 5. So what does this mean? It means that 0, 1, 2, 3, 4. So 0 is inclusive and 5 is excluded from our dataset. So it's gonna go from 0 to 1, 2, 3, 4, right? So this is exactly how we see. Right now this is the same dataset that you assigned here, but we need to apply the label. So what the label encoder does, it takes one single attribute, encodes it, and outputs a number of it, right? So let me just show you an example of it, right? So what I'm going to say, le dot fit underscore transform. By the way, this is the function for applying the label encoder on an attribute, right? So I'm just going to say that, and then what I can do is I can just copy this right from here, and let's say I wanted to encode the Outlook column, right? So this is the name of Outlook, right? So if I do that, if you see, it just instantly encoded the Outlook for us. You can see that it now has 1, 1, 0, 2, 2, 2, 1, 1, 1. So it encoded all those values, all those string values into. So it automatically understood that it's a nominal attribute, and it has only 3 categories, which were overcast, sunny, and rain. So it encoded them into numbers, just like that. Awesome. So now we know that we need to apply the same method on all of our attributes. So we can just simply use a loop for this, right? So I'm just gonna go ahead and say for I in dataset underscore encoded. So what I'm doing right now is I'm just going to go ahead and loop through all the column names using the for loop. And then what I can do here is I can just simply just say dataset. So we need to replace every single column. We need to replace every single ith column with the encoded values. So I'm just gonna say encoded values, right? So with that being said, now if I just go ahead and print the dataset underscore and encode it, you'll see that we instantly were able to encode all of our values into numbers. So it just worked right away like a charm, right? So now I actually kept the dataset separate, so now we can see what it did to our dataset, right? So if I just print my original dataset as well, so you can see that this is exactly what's happening here. So overcast means 0, so it encoded into 0. Rainy means 1, so it encoded into 1. And 2 means sunny, so this is exactly what's happening here, right? And then the temperature only had 3 attributes, so it encoded into 0, 1, and 2 as well. Humidity had only 2 attributes, so it just encoded it into 0 and 1 only, so that was just a binary attribute, right? Similarly, windy was also weak or strong, or simply true or false, so it encoded that into true and false as well, zeros and ones as well. And finally, the label set that we want to output, this is where we will be deciding, well, whether we want to play or not. This was also encoded into zeros and ones. So now you know that our output is going to be in either 0 or 1. So we can easily understand from 0 that it is no, and 1 means yes, right? So moving on, so I'm just going to go ahead and create a new text box here. And now what I'm going to do here is, now we need to create our model, right? So first of all, before we create our model, we need to divide our data into we need to divide our data into feature and label set. Right now this is a complete data with so our feature and label set is combined, so we need to separate them. So I'm going to call our feature set, I'm just going to comment here, it's called the feature set, right? And our feature set is going to be equal to dataset dot underscore encoded dot ilog, and ilog is going to be equal to so all columns, I need to include all the rows, and then from 0 to till 4. Okay, so with that being said, if I just print out X right now, you can see that it just automatically excluded the play, and we only have the input now. And we can do the same thing for the Y as well, right? So Control C and Control V. I'm just going to copy paste it right here, and then I'm just going to call this label set, right? And this is going to be Y, and we only need the 4th column, right? So if I print out Y right now, you can see that now we have the play as well. Awesome. So it's working fine, and we've done pre-processing our data, so we can now move on to the training part, where we simply just go ahead and train. But even before that, we need to apply a technique called, it's a very good technique. So like if you wanted to like test the accuracy of your model and how accurate it is, well, you can definitely use one thing that's called the train test split method. There are multiple methods for getting the accuracy or simply achieving the maximum accuracy from your model. One of that is k-folds cross validation, which is not what I'm going to cover in this video. We'll be definitely covering that in our other videos, but I'm leaving the topic for a separate video, so that it's a big concept, and I need to explain that in detail, so I'm not covering that. So this is exactly why I'm using the train test split function. So what is train test split? Well, from the name you can understand that it will divide our data, or simply split our data into training and testing set. And what does this really mean is that the training data is what our model is going to be trained on, and the testing data is what our model will be used for testing, right? So we will simply just go ahead and tell that, okay, this is the training data, and you need to get trained on this data, right? And then once it gets trained, we will show it all the examples that it hasn't seen before, and these are going to be the examples that which our model is going to be tested upon, right? So then now we will that's how we would know that our model is, whether it's actually performing the right way or not, because we will have the right answer for that, and we will see whether the model is actually going to, well, whether our model is that accurate or not, right? So we're going to do that now. I'm just going to go ahead and create 4 variables. First is the X train, which is simply the X data set and the training data set, right? So this is all the input data set. So X train, and this is the test data. So I'm going to do the same thing for Y. So Y train and Y test, right? So now I'm going to call the train test split function, and I'm going to just feed in the x and y I've created here, and then we can just pass in the test size. So what is the test size? Okay, so I just mentioned that we can split our data into training and testing. So by this name you can kind of understand that the test size means that we are going to take the 3%, or simply, so 0.3 means 30% of the data. So it's going to take 30% of the test data, and the rest 70% of the training data is what our model is going to get trained on. So it's going to see the 70% of our data, and then we are going to feed in that 30% that it hasn't seen, and then we will test whether it predicts the right answer or not, right? So this is exactly what we're going to do. Awesome. So now, with that being done, we can simply just go ahead and create our model. So model equals decision tree classifier, and decision tree classifier is going. So we're using cart, right? So I'm just going to go ahead and simply say criterion equals Gini. So this is how you actually specify that. Well, you need to use the Gini index for calculating this, right? So Gini is what we actually learned what Gini is, right? So this is simply the formula that we learned, that Gini is simply equals 1 minus probability of all the weighted sum, or simply the weighted probabilities of all of the attributes. So this is exactly what this little line is going to do here, right? And now we need to train our model. So how do we train it? Well, it's very simple. We simply just go ahead and call the fit function, and we simply just go ahead and fit our training x train and y train on this. And as I mentioned earlier, this is just a training data. So x train, y train, x train, y train. And then what we need to use for testing is the x test. So what x test has all the input attributes that our model hasn't seen, and y test is all the outputs for those input attributes that our model hasn't seen. And what x train is, it's all the input attributes that our model is going to get trained on, and the output for all those input attributes, right? So x train and y train are mentioned together, and x test and y test are mentioned separately, right? So with that being said, our model is done. So now if we just go ahead and say, let's say I will simply call the predict function for this model, and let's say I wanted to predict something, so I will just simply give it an input of 0, 0, 0. So let's see what our model says. So our model says 1. 1 means yes. So 0 means I'm saying, well, the outlook is overcast, and the temperature is cool, the humidity is high, and the wind is also not strong, it's weak, it's false, right? So it's outputting it's giving us the output as 1, which means you can go and play. But let's just say we change the test size to 2. Well, it's giving us the same output, but let's just say I use the exactly same I'm going to use the exactly same example that we used as to construct our decision tree. So I'm going to use this example, right? So what this example says is that we need to say outlook as overcast, temperature is hot, so temperature hot means it's 1, and then we also need to say, well, humidity is high, so high means 0, right? So I've set 0 here, and wind is strong, so strong means it's true, so true means 1, right? So I'm going to do this. So theoretically the answer should be yes, right? So let's see if our model also says yes. Wow, it says yes. On the other hand, and that's pretty much because overcast will automatically, so you know that outlook on if outlook is overcast, and so it's automatically going to just go ahead and say yes. But what if we change this to sunny? Let's see what the output for sunny is, right? So I'm just going to go ahead and change to sunny, and sunny means it's going to be 2. So I'm just going to go ahead and put 2 here, okay? So now our output is automatically no, and that's totally perfect, right? But what if I just put 3%? Let's just say we take that's 30% of our data. So you can see that right now our model is training pretty much right, because, well, it's doing the right thing. And now let's just find out what's the accuracy of our model and how good our model is. So for that, what we can say is we can just simply say score model.score, and this is exactly what you do for score. And then what you can do is you can just say x_test, y_test, and you can see the accuracy for our model is 6%, which is not that good, because obviously it should just get trained. But let's say if I increase the training size of our model, so it's a little bit not good. So obviously let's say I increase the training size of it. So you can see now our model is 100% trained, but the problem is now we don't have any other example to get to test it, right? That's the problem here, right? So this is exactly why we need to give it a good training and testing size, and we need to vary the training and testing size in such a way that our model works properly. So with that being said, thanks a lot for watching my video. That was a little implementation that I did for for the same data set that we learned and we created our mathematical background upon. And one thing we can do definitely is we can just simply use, like, let's just say if model dot predict, and let's just say I'm just going to go ahead and give it an input. Let's say the input is going to be 0, 0, 1, 1, and if this whole output is equal to 1, then you can just say yes, you can play. Otherwise, if it outputs no, you can just simply say print no, you can't. Right? So this just makes things very interesting, right? So now if I just do this, okay, we have an invalid index. What is wrong with it again? Oh, I forgot the equal sign here. Error expected. Okay, so we accidentally inputted gave it a 3-dimensional array. We need to give it 2 dimensions. So you can see now the output is yes, you can play. And if I change anything else precisely, let's just go ahead and just change this to 0 as well. So it just it just simply goes ahead and decides based on the data, right? Awesome. So it's working pretty fine, and this is exactly the implementation of the example we learned earlier, right? So I hope that helped, and I hope that you learned something new from this video. So if you like this video, don't forget to like and subscribe to my channel. And so I will be continuing. I will be uploading more videos on more models, and we will be learning all the mathematical backgrounds and implementation of every single model included in machine learning. So with that being said, don't forget to like and subscribe again. Thanks a lot.